Hello and welcome to SBG Support Center. With the help of my colleagues from the Technical Support Department, we are going to see in this video how to make a magnetic calibration. It's mandatory to calibrate your magnetometers because of hard and soft iron distortion. FYI, hard distortion is caused by the summation of the magnetic fields generated by Earth and those generated by magnets. This effect will shift the measurement made by the magnetometer by adding a constant offset. And soft distortion is caused by ferromagnetic materials. Ferromagnetic materials don't generate their own magnetic field. Instead of that, they are reacting to existing ones. And generally, it's because of Earth's magnetic field. Now that you know why do we make magnetic calibration, let's see how we do that. The purpose of a magnetic calibration is to map the magnetic environment of your device. And in order to do that, you need to measure the magnetic fields of your device on different orientations. And a minimum of 9 different orientations is required. And there is 2 types. There is the 3D calibration, and it's the one that we always recommend because it provides the best performance. But in some situations where you can't move your device or your vehicle on 3 dimensions, we recommend in this case to use a 2D calibration. But it's only valid on a 50 km radius, and you need to provide the date and the position of your device on the latitude, longitude, and altitude. First, you will open SBG Center. Then, after configuration, go to initial position and date. Because if you're using magnetometers without GNSS input, you need to know that Earth's magnetic field is slowly changing over the time, and we call that secular variation. So it's necessary to configure position and date to compensate this variation. Then go to Hidden, Magnetometer. Here in Error Model, it will give you the choice between normal and noisy magnet tolerance. This last one is used in case you're in a disturbed environment. In Hidden Rejection, we always recommend to choose Automatic Hidden. Now you can click on Calibrate Magnetometers. In order to illustrate this process, we made a magnetic calibration in the middle of a field to avoid magnetic interferences. We installed an ellipse D on an iron rod, and we added an antenna to obtain precise information about date and position. Now let's click on Start Acquisition. Now my colleague will rotate the INS on multiple orientations. He is moving slow so the dots will be close enough to form a complete circle. Let's click now on Stop Acquisition, then on Calibrate to see the result. Before deviation is about the distortion of the local magnetic field before the calibration. After deviation is after applying the calibration algorithm. STD-dev is the dispersion measurement around the expected value. The average deviation is representative of the magnetic field. Maximum deviation is the worst case encountered during the calibration. And confidence is to express the confidence that the algorithm has about the standard deviation value. Let's see this time what is going to happen if we do everything wrong. As you can see, the points are really distant from each other. Also, when I click on Calibrate, a pop-up window appears as a warning, telling exactly what we did wrong. Here, for example, there was too much dynamic, and there was a non-constant environment perturbation. And this is because my colleague was moving too fast and not on all the axes, and he was really close to a computer and a phone that constitutes an unstable magnetic environment. So in order to get good results, it's important to stay as far as possible from any external source of magnetic disturbances. This is the end of this video. I hope you learned a lot of things with me. If you have any question, you can call our technical support team and we will always answer. Thanks for watching this video. See you on the next one.